Hello everyone. So we are presenting our major project, that is Fashion Mist. Me and my teammates, that is Narsima Kulkarni, Neeraj Kumar, Praveen Kumar and Saurabh Gadak, under the guidance of Dr. S.M. Joshi sir. So our project is based on artificial intelligence and machine learning, where our model take input image of any extension from the user and process it and tells us whether that type of accessory is present in our dataset or not, and also tells us the category of that accessory, whether it is a shirt, t-shirt or an ankle boot or anything else.
So the working model basically involves image pre-processing, feature extraction, machine learning algorithm, and model knowledge. So in pre-processing, we perform a real image, resizing image, remove noise and segmentation. So in read image, we are storing the path of our image in dataset. In resizing the image, we are resizing the image to a standard size, and in segmenting we are going to segment the image, and based on the background we are storing it in the folders. And then in feature extraction, the pixels will be in the form of 3 matrix, because we are taking a colored image, and then we are applying a filter to the matrix. So filters are basically used to detect specific parts in the image. We are basically multiplying image matrix with filter matrix to detect specific part in the main matrix. And then we are applying RLU. So RLU we are applying because we need to remove the negative values, and then we are applying max pooling to get new featured map, and by doing so we can reduce matrix size for easy computation. So then we flatten the matrix for classification, and the final output will be called as softmax, through which we are comparing with the test data. The test data also involves the same process as the train data. The final softmax will be compared, and then we detect whether it belongs to particular category or not. So next we will see the implementation part.
In implementation part, we have imported some standard libraries such as image data generator, sequential optimizers, and preprocessors, which are very important for implementation of this project. Then we have downloaded the image of size 224, as this image is required for VGG model. VGG 16 is a convolution neural network which has 16 layers. Then we move to loading and training of data. In loading and training of data, we have downloaded 70 images belonging to 6 different classes. And in training, we have trained the model with 7 iterations, and we are able to get an accuracy of 98%. Here we are graphically representing our training. As we can see that as the iteration increases, you can see accuracy has also increased. And as the epoch of iteration increases, we can see the inconsistency has reduced. Then we have confusion matrix, which is a 3x3 matrix. This also helps us in achieving how accurately our system has been trained. Now we continue with the testing part.
This is the testing part of our model. Here we are testing for ankle boots, bags, dresses, pullovers, sandals, t-shirts. We have created our own dataset. This is our dataset which we have created for training and validations, in which there are categories same as told: ankle boots, bag, dresses, and here we have some images which we have already stored. So now we will provide an input directly from the internet, or we can get a picture from our PCs also, and we will check whether our model will recognize it or not. So now we will provide the path for the image, and we will see how the output will come.
Yeah. So this is where we have to provide the path of our image, so that our model will test whether that image is present or whether what kind of image it is. So we will first take a random bag image. So here we will download that image from the internet, as you can see. So I have downloaded it. As you can see, it is downloaded, and I will put the path of that particular image here, and I will run that code, and you can see that it is running, and you can see that it is showing that it's a bag here with an accuracy of 66%. As you can see, it will compare all the this particular thing with all the labels, and it will show that the bag is 66.22%. that means it's a bag. Now we will take another accessories, that is a dress. So we will take a random image, we will download it same, and we will copy the path of that particular image, and we will put that image here, the path of that image, and we will run that. So here you can see, so here you can see it is showing that it's a dress. So it is showing us that the thing which we are giving the output, it is showing that it's a dress. Now we will put the third output, that is a sandal, a random sandal, and I will same download it from the internet, and I will copy the path, and I will paste that path link here, and I will run that code. So here you can see it is showing that that particular thing is a sandal. So it's showing with an accuracy of 90.95%. So now you can see that our model is running successfully, and it is showing the right output, the expected output that is present in that image. So we can use images from our own data set and also from the internet, wherever we want we can use that. Thank you. That's all for our project.